let's get this show on the road. All right, so we're going to start looking at log equations this time, right? So we looked at exponential equations. That was the part 2 that we did earlier on. And we're going to look at log equations. So let's start with the one that you see in front of you. If I just handed that over to you and said, solve this. Hopefully everybody's back with us, by the way. Hopefully everybody is keyed in and locked in and ready to go. If I just gave this to you and said to solve it, hopefully everybody would at least have an answer, even if I haven't taught you anything yet. Bear in mind that this is a base 10. Does anybody know the answer? Convert to exponential first, yeah. But do you know the answer right away? Can you think of a number that would make this magic happen? What value of x would make this happen? Hussein, you're right. Convert to exponential, we're going to do that. But Alexander is right. You see Alexander's answer, he says it's 6. Because he knows that the log of 10 is 1 in base 10. So he's right. But let's now come with a more formal approach to this. Let's come up with something that's a lot more formal. So what Hussein said is exactly what we're going to do. We're going to convert this to exponential form. So remember, this is base 10. So that should be your clue as to what the next step should look like. It should be that this step, this x plus 4 here, should be equal to whatever the base is to the power of 1. Okay? So now we should be able to solve this. Or x is equal to 10 minus 4, which is of course 6. So you're right. Now, one of the things I have to warn you about is that occasionally, when you're solving these log equations, you get what are called extraneous roots or extraneous, I'm going to write that word down. And I've used this term before. I forget in relation to what, but I know I've used this term before. Extraneous roots or extraneous solutions. Oh, I think it was when we were doing rational functions. An extraneous solution is a solution that, although algebraically it makes sense, it doesn't work for this situation because of restrictions. Now, the only restriction on this answer is that x had to be greater than 4. How do I know that? Because if I took this x plus 4 and set that equal to, and said that x plus 4 must be greater than 0, then it means that x must be greater than, am I saying that right? Let me just make sure I'm saying that right. Yeah, x plus 4 must be, right. So if I said x plus 4, I don't think I'm saying that right, actually. I'll fix that in a minute. If x plus 4 is greater than 0, and I want to see what the condition is, then x, if I subtract 4 from the two sides, x must be greater than minus 4. Yeah, I'm saying it wrong. X must be greater than minus 4. All right? And that's because we can't take the log of a negative number. So this thing inside here that we're taking the log of, that thing must be greater than 0. It has to be positive. Can't be negative, can't be 0. So x has to be greater than minus 4, which clearly 6 is. So this solution is not extraneous. We can take 6 as an answer. But there are times that the answer, minus 4. Thank you very much for correcting me. It must be minus 4. X must be greater than minus 4. All right. So let's get to the second one. Now this one is similar. Let me just move these up here. Now this one is similar, except it's a base 5. But what you heard earlier on from, I think it was Alexander who answered the question earlier, is that maybe you can even figure it out without doing all of this fancy stuff. But no, we're going to go with converting to exponential first. So we're going to do that. So this in exponential form would be the 2x minus 3 is equal to 5 to the power of 2 because it's a base 5. That's the exponential form right there. Okay, so that means that 2x minus 3 is equal to 25, and therefore 2x is equal to 28, and x is equal to 14. Again, is there anything wrong with this answer? We should go ahead and check what our restrictions are 2x minus 3 must be greater than 14. Well, sorry, 2x minus 3 must be greater than 0. Solve that. I believe you would get that this answer of 14 is quite fine. So, in fact, what you can do sometimes, rather than having to solve for the restriction, just plug that number back into the original equation and see if it works. Does 14 work? Does 2 times 14 minus 3 give us an answer which is undefined? No, it's not. It's not, because I can take the log of the number that comes out of putting 14 into this expression, so we know our answer is good. So nothing wrong with this answer and nothing wrong with this answer. Both answers are fine, right? Okay, yes, go ahead, Quinn.
Sorry, can you explain why we didn't do or plug 2x minus 3 in to figure out the restriction?
Okay, we could. I'm not, so you're saying why we didn't actually plug 2x minus to get the restrictions? If the question was to compare it against the restriction and to state what the restrictions are, then yes. But what I'm saying is if you can just simply eyeball it and say, does 14 work in the original equation? Because when we get to some of the questions in a little while, it's going to be very obvious that the answers that we get cannot work. But you can just eyeball it and say, putting 14 into this does not cause this to become negative, does not cause us to get a number which we can't take the log of. And that's why I'm saying it's okay for us to take 14 as an answer. We could, though, just to verify it, take 2x minus 3, set it greater than 0, and solve it and see what is the actual restriction on the answer. But no, 14 is a perfectly legitimate answer. So hopefully that answers your question. We don't really have to find the restrictions every time. If we can just show that the answers that we got are acceptable, then that's good enough. Okay? All right, let's get to the next one. Okay, this one is different now. It's got logs on the two sides. So what do we do this time? Let me take some suggestions from the room. I got the log of x minus 1 is equal to minus the log of x plus 2. Wow. What do we do now? There's logs all over the place. Any ideas as to how we might be able to solve this one? Looking at the room here and hoping somebody is going to say, oh, why don't we try this? Or why don't we try that? How about we put all our log stuff together on one side? How about we do that? Let's try that, see how that works. So Kelvin says, yeah, oh, and then use the product law. Well done. So we'll do that. So Kelvin says, why don't we take this log, this is what your homework is on, by the way, of the x minus 1, right? And add that to, because this is a minus log on this side, the log of x plus 2, and set that equal to 1. So basically what I've done is I've taken this thing, put it on this side, taken this minus 1, put it on that side, right, as a plus 1. And Kelvin, if you look at what Kelvin just said there is, why do we use a product law now? The product law says the log of a sum is the same as the log of the product. So the log of x minus 1, log of x plus 1 is the same thing as the log of the product of these two things, x minus 1 times x plus 1. I'm missing the 2, he says. Oh, I certainly am. Yes, you're absolutely right. Thank you very much. A good thing that you guys are so vigilant. I shouldn't be allowed to get away with anything like that at all. Plus 2. Thank you very much. Okay. All right. And of course, to finish this up, is equal to 1. Now, there is no base that's stated here, so it means that we're dealing with a base 10. So when I'm putting in exponential form, I'm going to be assuming a base 10. So here we go. So x minus 1, taking away the logs now, times x plus 1 is equal to 10 to the power of 1. That's my exponential form right there. Which means, well, how do I solve this now? I guess that's the question I should be asking you. X minus 1, x plus 1, 2, not 1. Oh, jeez. Is it still? Oh, man. I can't believe I'm still making that mistake. I can't believe I'm still making that mistake. Yeah, thank you. Thank you very much. Yeah, you're absolutely right. Absolutely 100% right. Okay, so apart from the error, apart from the obvious error, thank you very much. Yeah, no, Donna, no, you have a right to be confused. All right. All right. Thanks, Quinn. Okay, so why is there a x plus one? X plus one. Is it just a mistake I was making there, Hussein?
The fact that it was X
Oh
plus
yeah, 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 yeah. Okay, because why is that? Because it's wrong. That's why. Okay, let's keep going. What happens next? What happens now? What do we do now? Expand the product of the binomials and bring 10 over. Wow. I'm going to turn this class over to Kelvin any minute now. Okay, so let's do that. And hopefully we don't have to spend a lot of time on that. The x times that gives me x squared. Then I'm going to have minus 1 and 2, which is plus x. And then minus 2 is equal to 10. 10 to the power of 1 is obviously 10. And then, yes, he said bring the 10 over. So it's going to be x squared. You just see how to solve a quadratic. Plus x minus 12. That's minus 2 minus 10 is equal to 0. Okay. Well, I think the next step should be pretty obvious, don't you think? Right? We did this because we want to be able to what? To solve this. It's a quadratic. It's an obvious quadratic. So what do we do now to solve this? We factor it. Good. So let's factor. And let me go. No, don't put anything in the chat, please. Let me see. Let me go check it with somebody here on this. Davina, can you tell us what this factors to, please? Davina, your time. Are you there with us, Davina? Perfect. Can you factor that for us, please? X squared plus x minus 12. And tell us what you get when you factor that. Let's just give Davina a chance. I don't want anybody else putting anything in the chat here. You're with us, Davina? You know what you're about, right? Do you need help, Davina? You know you just ask. If that's what you're looking for, you need to just say that. Okay? I'm asking you to factor this line. Can you factor that for us, please? Okay, so you're saying x minus 3, x plus 4. Does that make sense? Of course it does. Of course it does. So if that's equal to 0, remind me now what x is. Donna, how about you? What is x actually equal to, if that's the case? Donna, it's over to you now. So x equals minus 4 and 3, she says. Okay. Now the question now is, again, we don't really have to just look at what all the restrictions are, but let's just look back at this and see, would these numbers work? Does minus 4 work in the original equation? Let's go back and try minus 4 and see if that works. So I'd have the log of minus 4 minus 1. I'd be finding the log of minus 5. And then minus 4 plus 2, I'd be finding the log of minus 3. Sorry, minus 1. Minus, what is that? Minus 2, sorry. Does that make sense? Is that okay? Can I use the minus 4? Is this answer an okay answer or not? That's my question, right? Can I go with the minus 4? Alexander says no. Brandon and Hussein are on that same wavelength as well. And that answer is correct. The minus 4 is not an acceptable answer, right? That's what we're calling an extraneous root, an extraneous solution. Right? Does the 3 work though? right? Can we go with the 3? Let's go back and look at the question again. So that's the log of 3 minus 1 minus the log of 3 plus 2. Can the 3 work? And Alexander is saying yes. What do other people think? Right? Does the 3 make sense? Can we go with the 3? Absolutely. So this answer is acceptable. So our answer is that x is equal to 3 only, right? Never mind the fact that all the math gave us these two answers. The minus 4 might look like a great answer until you put it into the original equation and discover that it's an extraneous answer. We can't use it. We have to dismiss it. Okay? All right, good. Let's see if we can do some more of these. How about this one? Let me bring this down some more for you here. How about that one? The log of x cubed minus log of 2 is equal to the log of 2x squared. Logs all over the place again. Any suggestions as to how I might be able to solve this? Is the product law going to help us out here? Or is there something else that we need to do? Or the quotient law, I might add, because this doesn't look like we can use a product law. This looks like it might be a case of the quotient law, right? So how would this look if I was writing it with the quotient law? The log of x cubed minus the log of 2 is equal to the log of 2x squared. All right, I like to ask for help. Hussein, can you help me with this one? Is there any suggestion that you have that might help us out here? Any recommendation? Any way that I could rewrite this that might help us to make more sense of it? Hussein, what do you think? So tell me what you think might be a good idea. Any ideas? Move the log 2x over, you're saying, to the right-hand side. We could do that. We don't really have to, right? Because can't we combine the 2 on the left-hand side right now? Can't we not? Is there any way that we can? So Hussein is what I'm asking. Is there any way that we can combine these two using the quotient law? By the way, Hussein, I'm not saying what you said is wrong, because it's not, right? That could be done as well. But what do you think might happen if I were to combine those? It's not just for Hussein. I mean, I am asking Hussein, but I'm asking everybody else as well. How can I rewrite that using the quotient law? Kevin, what do you think? Kevin, let me go to you on this. You generally have a lot of ideas about these things. Can I rewrite this using the quotient law? What would it look like? Could this question be solved multiple ways? Oh yeah, like most math questions, and I've always stressed this, right? There's always more than one way to solve a math question. Almost every time you can find different strategies. Roma just came up with something I never thought of before as a step in the question that we just did a few minutes ago. So absolutely, yes. All right, let me ask the question again. Kelvin, do you think that we could write that left-hand side a different way? What do you think, Kelvin? Okay. Log of x to the power of 3 divided by 2 in quotient form. Okay, good. So what you're saying is this. The log of x to the power of 3 divided by 2 is equal to the log of 2x squared. And that looks very bad. So let me try that again. This is supposed to be a 3. Okay, does everybody agree with what I just wrote, first of all? Isn't that the quotient law for logs? That if I have the log of something minus the log of something else, that I can write as a log of the quotient of those two things, the x cubed over the 2. Okay, good. Excellent. Thank you, Donna, and thank you, Brandon. You agree with me. Okay, what do we make of this? The log of one side is equal to the log of the other side. Any thoughts on what my next step might look like? Think back to when we're doing trigonometry. Remember when we were solving, I think it was a cofunction identity question. And eventually, we had the sine of one side was equal to the sine of the other side. Actually, I don't think I did that question with this class, when to think of it. May not have. Yeah, okay. The logs cancel out. Look at you, Hussein. He's right. If they're both the same base, now they're both the same base. There's a log 10 on the left and a log 10 on the right. If you have a log of this circle being equal to the log of this circle, then those two circles must be equal to each other. That's what we're saying. So x over x to the power of 3 over 2 is equal to 2x squared. Absolutely 100% correct. All right, is everybody clear on that? Does that make sense to everybody? All right, I want to make sure that that step makes sense. If the two, if it's a log of the left is equal to, as long as the two bases are the same, let me just be clear on that. As long as the bases are the same, then we're good to go. We're good to go. Now, I'm going to suggest that we cross multiply to get rid of this 2 that's at the bottom here, right? I don't like fractions getting in the way too much. So why don't we multiply 2 on the left and 2 on the right? The fractions kind of complicate things a little bit. So 2x cubed over 2 is equal to 2 times 2x squared. All right, hopefully everybody's okay with that. And the whole point of doing that was to get rid of the denominator of 2 on the left. So now I have x cubed is equal to, this is, no, remember, I wasn't this is 2 times 2x squared, so that's actually 4x squared. Right, it's okay for me to multiply this 2 times that 2 to give me 4x squared, right? I'm not squaring it was 2 times x squared. It's 2 times 2 times x squared, so it's okay for me to put 4x squared there. All right, how do I solve this now? There is one obvious solution. Correct. Thank you, Brandon. That's exactly right. We're going to put the 4x squared on the left-hand side, so we're going to end up with this. X cubed minus 4x squared is equal to 0. And then Brandon says, factor out, but factor out what? What's the common factor here? What is the common factor? The x squared. Good. We're left with, obviously, x minus 4 equals 0. So, we're getting very close to the solution. The zero product law, I'm going to remind you of this. Thank you, Chrisania, and thank you, Alexander and Brandon. The zero product law says if I multiply two things and get 0, then one of those things has to be 0. So either x squared equals 0 or x minus 4 or x minus 4 equals 0. So we actually have two solutions. What are those two solutions, by the way? Let me coming back into the room and see if I can get some help on this. Lance, let me go to Lance on this. Chrisania. I couldn't hold Chrisania back. She was too eager to put her answers in. Okay, since Chrisania, and we know that Chrisania is right. So Lance will come back to you. She says, 0 and 4, and she's right. 0 and 4. But are both answers, but only 4 works. Let's go back and look. Does 0 work in the original? Well, I ended up with the log of 0 cubed, and we know that 0 is a no-no. And another 0 over here is another no-no, so that's not going to work. But the 4 does, right? So this is extraneous. This one is extraneous. But this one is good. So my answer is that x is only equal to 4. That's the only answer that makes sense in this case. Let's see what else we have here. All right, let's try this one. Lance, I almost feel as if you got off lightly on that one, but anyway, we'll move on. How about this one? Let's see what else we got. Natasha. How about Natasha on this one? Natasha, where would you start with this one? What's the first thing you would do with this one? Oh, it's not one like I did before. No, I haven't done this one before, no. So Natasha, what do you think? Where's Natasha, by the way? There you are. Okay, so what do you think we should do first? That's fine. So Natasha, I want you to think about the quotient law that we learned yesterday. These things are being subtracted, so we should be able to take the log of the quotient of these two. Does that make sense? Remember the quotient law that we did yesterday? Does that ring a bell, the quotient law, Natasha? And you don't have to apologize, by the way, for asking for help. That's we all do from time to time. That's fine. Okay, so why don't we state the left-hand side as a quotient then? Rather than as a difference, we can state it as a quotient. Do you see what I'm saying here? Does that make sense? I want you to state the left-hand side as a quotient, not as a difference, because a difference and a quotient for the quotient law are one and the same. So let's see if that will help you to put something together on the left-hand side. If you need more than that, you let me know, which is fine. But I'm looking for a quotient, like what we did before. Yeah, the ones that we did before were either a quotient or a product. This one is a quotient. So yes, very similar to what we did before. In fact, let me go back and show you the one we did just before this, which was this one here, where we were subtracting these two things from each other. And then we ended up taking the log of the quotient. Quotient meaning one thing divided by the other. Okay? Let's go back to this one here. I'm not rushing you, by the way, so you take your time and tell me when you think you have an answer. So we write that down. It's the log of the p plus 5 over the p plus 1. That's equal to 3. Good stuff. Thank you, Natasha. And then what comes next? I'll just throw that out to the room. What comes next? What's the next step in solving this? Cross multiply? Well, not quite yet. There's a step that comes before the cross multiplication, isn't there? We're dealing with a log equation right now. So before we cross multiply, we have to, there you go, Prasanna. We have to find the inverse of this, which is an exponential function, and say that p plus 5 over p plus 1 is equal to 10 to the power of 3. Why 10? Because it's a common logarithm. It's a base 10. All right. So let's work out what 10 to the power of 3 is. So p plus 5 over p plus 1. This takes us back to our work with rational functions. Is equal to 1,000. And somebody said cross multiply, which I agree with, by the way. So let's put that over 1. And let's go ahead and cross multiply. What does cross multiply look like? What do we multiply by what? Right? Exactly what do we multiply for cross multiplication? Can somebody help me with that, please? What are we cross multiplying here? What exactly are we cross multiplying here? Lynette, how about we ask you that one? Aroma says, okay. All right, so I put down what you said. So you're multiplying the p plus 1 by 1,000. Good. So and that's equal to the p plus 5 is equal to 1,000 times the p plus 1. Right? We take the bottom of this side and multiply it by the top of that side, the bottom of this side, and multiply by the top of that side. Well, the bottom of one side is just 1. That doesn't really affect it. So what we have now is this. P plus 5 is equal to 1,000. We just expand it. P plus 1,000. Right? Thank you, Alexander. And really all we need to do now is isolate our P. So why don't we take the P from the left side and bring it on the right, which gives us 999 P. Take the one on the other side and put it on the left. So that gives us 5 minus 1,000. So this, of course, is minus 995, which is equal to 999 P. So P is absolutely equal to, yeah, you're right, Alexander, is actually equal to minus 995 over 999. Now, does this answer cause a problem? Let's go back up and look. We always have to compare that to the original. This number that we're looking at is very, very close to minus 1. Very, very close to minus 1. Just a little bit less than minus 1. So does that cause an issue here? Now, can that work in the second bracket? And go ahead and put it on your calculator right now. It's a negative number. So negative 995 over 999 plus 1. Is that still negative? Because if it is, we've got a problem, right? So I'd like you all to check that out for yourselves right now. Put that in your calculator. Minus 995 over 999, excuse me, plus 1. No, it doesn't work in the second bracket. Oh, so you're saying that if I put it in the second bracket, I'm going to get a negative? Is that what you're saying? That number plus 1 is negative? Are we sure about that? Are we sure about that, Hussein? Did you try it for yourself? I know it's a negative, but when you put it with a 1, plus 1, is it still negative? Lynette is saying, no, it does work. And I believe it does. Of course, if it's 5, then clearly that's going to be 5. So this answer is perfectly acceptable, right? And there are actually no other answers. So that answer works just fine. Okay, 2 more questions. And then what I'll do is I'll let you get started homework. Actually, I might try something I was thinking of doing with you a couple of days ago, which takes us back to the trig unit, but we'll get to that if we have the time. We should have the time. How about this one? How about this one? The log of x squared minus 5x equals the log of 6. What do you think, folks? How do we solve this? We've done something like this before, haven't we? Take away the logs. Thank you, Branad. Right? It's a log, and they're both base 10. So that means that we can just simply say, since it's all logs on one side equals all logs on the other, that I can just simply banish the logs. If they're both the same base. Let me just be clear on that. If they're both the same base, they have to be the same base for this to work. So that means that I can now say, since it's a log of this equals a log of that, I'm just going to say that x squared minus 5x is equal to 6. Does that work for everybody? Does that make sense for everybody? All right, I want to make sure everybody understands what we just did. Both sides are logs. They're both the same base. It's okay for us to just simply ignore the logs if the bases are the same. So all we have to do now is just follow through. Minus 6 equals 0 and factor. And that sounds like a job for, let's see, Jenna. Jenna, can you help us out, please? Can you factor that for us, please? What are the factors? In this case? You know what I'm asking to do, Jenna? Are you clear on what we're doing? Okay, sure. x minus 6 and x plus 1, she says. I agree. So what does that mean in terms of a solution then, Jenna? Let me just stick with you on that. What are the solutions that we have so far? Then we're going to check those out and make sure these solutions are good. 6 and minus 1, she says. 6 and minus 1. Okay, but do they work? Do they work? Can 6 work and can minus 1 work? Let's test that out. If I put 6 in, I'm pretty sure we can all agree that 6 is going to be good. But how about minus 1? Does minus 1 also work? Right? I know sometimes we make the assumption that once it's a negative, it's not good. Does this negative here cause a problem? Right? Let's just test that out. Does the negative 1, is that a valid solution? Yes or no? Let me check the room on that. Can I use both 6 and 1? Quinn says no. Alexa says yes. Chrisania says no. Alexander says yes. So we're all over the map on this one, right? Well, let's see. Let's just test it out, right? Remember, this thing here, the log of 6 is just some number. X squared minus 5x has to be positive, right? So let's test that out. So x, oh, there's another one down here. So x squared, and if x is 6, let me just put the 6 in. Okay, I think the 6 is, I think everybody accepts that the 6 is good. So let's not bother with the 6. Let's put the 1 in and see what happens. So we're going to have minus 1 squared. Remember, it is minus 5 times minus 1. Okay, this is positive, so that's just 1. This is plus 6, so that's plus 6. Guess what? Plus 5. Plus 5, I'm sorry. All kind of rubbish today. Guess what? It does work. So this answer of minus 1 is absolutely positively fine. So it does work. All right, so let's just do this last one here. Do you have any more after that? This is the last one. We'll make this one the last one, and then I'm going to get you to work on your homework. I'm going to set something up for you in the meantime while you're working on the homework. So I'll bring you back into, don't leave the classroom. You can't leave, you can't leave until the end of the class. But let me just ask you to walk me through this last one here. Quinn, let me start with you. Quinn, how would you start this question? What would you do first? The log of x plus 5 is equal to 2 times the log of x minus 1. Give me some ideas as to what you think might be a good first step for this one. Let's just hear what you think. Log of x plus 5 is equal to 2 times the log of x minus 1. Any ideas whatsoever? Quinn, are you there with us?
Yeah, I'm here.
Perfect. Give me some ideas as to what you think might work here. And we're not rushing you. And if you need a little bit of a hint, I can give that to you as well.
Well, they're both log-based 10s, but there's a 2 on the other side. I was going to say cancel, and have 1 only on the right side, but I don't know if you can do that because I think that probably makes it.
Yeah. Okay. So let me give you a hint then. Okay. So you're right. That 2 kind of does seem like it gets in the way a little bit, unless we can make this side here, if we can apply the power law to that, the power law of logs to that, that might make that side look a little different. What do you think? Can I rewrite?
Yeah, I was going to say that, but I didn't think that made sense. So it would be log of x minus 1 squared.
Nice. So that's what we're going to do. We're going to say the log of x plus 5 is equal to the log of x minus 1 squared. Because the power law says we can do that. Either the 2 can be in the front or the 2 can be an exponent. Okay. So Quinn, back over to you now. I think the next step should be a little bit easier now that we've done that, right? What do you think?
Cancel the log.
Absolutely. Thank you, Quinn. So we're going to say that x plus 5 is now equal to x minus 1 squared. That's exactly right. Okay, thank you, Quinn. Let's see if we can get somebody else to chime in on this. Let's see. I don't know. Hunayn, your time. Hunayin, are you with us? Where's Hunayin? Perfect. Hunayin, what do we do now? We need to solve this equation. And of course, we also have to check our answers and make sure our answers are good at the end. But let's just finish solving this. What do we do next? What do you think? What's your next step? I have to leave for Friday prayer. I was just about to say that. Can you at least, okay, before you go, fine, that's fine. But can you at least start to solve? If you had this equation to solve, what would you do first? And then you can go to Friday prayer. I don't have any problem with that whatsoever. What would you start by doing? Because I'm sure you can give us at least that parting message before you go. What would your next step be? And then we'll take it from there. What would the next step be? Any ideas? Any thoughts? I'm asking you to solve for x. X plus 5 on one side. What if I took away the bracket on the left? Maybe that might be a little easier for you. Just said x plus 5. Oh man, that's so ugly. Sorry. So now we're just saying x plus 5 is equal to x minus 1 all squared. What do you say? Just give us a parting, and are we yes, we're solving for x, absolutely. We are solving for x. So give us that step that comes next. Bring the 5 to the other side. Okay, we can do that. But then how does that help us to solve for x though? That's the thing I'm not so sure about. Because you still have the x on the right and the x on the left. So there must be something more that we need to do. What do you think? Then you can go after that. Any thoughts before you go? Not sure, eh? All right, go ahead. Hopefully you're going to watch a video later on to make sure that you catch up with us. Brendan, do you have any ideas as to what we might be able to do next? Brendan, are you with us? Yeah, what do you think? We need to solve for x. Just received a call from, okay. All right, while you're doing that, let me see if Brandon can give us a little insight here. Brandon, can you help us out? Brandon, are you there? Okay, Brandon, what do you think? Expand the right. Thank you very much. Let's do that. X plus 5 is equal to, you say x squared minus 2x plus 1. Good. By the way, you're at the stage now where you should be able to expand the bracket on your own without me going through every single step. But Brandon is right. It is x squared minus 2x plus 1. You're absolutely right about that. Brendan, are you back with us now? Okay, then you factor. Sort of, but we can't factor just yet. We have another step we have to do. Okay, Natasha is jumping in and saying, move the 5 over. Only the 5, Natasha? Or both? Okay, good. Let's move both the x plus and the 5 to the right-hand side. So that would mean that we'd have this. X squared minus 2x plus 1 minus x minus 5. Can we all agree on that? What is Christania doing? Christania, could you please hold off on those answers? I don't even know whether that answer is right or not. We'll get to that. Let's keep going. Collect like terms, good. So x squared, so that will be minus 2x minus x, which is minus 3x. And then 1 and minus 5 is minus 4. And yes, we should be able to factor this. And the factors are x minus 4, and of course x plus 1, which means that x is equal to Christiania is so far ahead of us there, 4 and -1. But are we good? Are we going to take both of these answers? Alexander says only the 4 works. Is that right? How about the -1? We don't want the -1. We don't like the -1. What's wrong with the -1? Let's go back and look. Now remember, I know what Christian is saying, they both work because you're thinking that you're squaring this, but you have to go back to the original. And the original equation does say 2 times this. So because putting -1 into this doesn't work, we only unfortunately have to accept the, what's the other question again? Only the 4. We can't take the -1. I know in this form it would be okay, but going back to the original equation, right, we have to say that the -1 is going to cause a problem. So it means that this -1 is extraneous. But the x is equal to 4 is fantastic. We're good with the 4. Right? 4 is fine. All right. Now that's the last question I had on the stuff that we have. We have approximately 20 minutes left in the class. Yeah, you have to use the original. I know. I can see what you did, Christiania. About 22 minutes left in the class. I want you to go over to the calendar, download that homework that I put there. You can copy the questions off if you like, or you can just print it off depending on whether you have the printer or whatever you want to do. That's fine. But there is a bunch of, it's not from the textbook this time, right? If you go ahead and get started on that, I'm going to set something up for you, which I think might be a little bit of fun on a Friday here that I'd like you to look at. So I'm going to stop recording now, right? You got to stay in the room for the rest of the class. And like I said, I'm going to come back to you in a minute with a little exercise, which you might find interesting. Okay? So I'm going to stop sharing this and stop recording.